restart this computer. Okay, let's start. Hi everyone, we are group 16 and we are working for the determinants of credit limits, a regression analysis of demographic, behavioral, and financial factors.
I'm Hayden Walters.
I'm Luhani In.
I'm Mary Wang.
And I'm Tian Xu.
So let's look at credit cards and college students. First, what is credit limit? By definition, credit limits is the maximum amount a lender permits a borrower to use. It plays a critical role. For college students, credit limits influence their daily purchasing power, their emergency preparedness, and early credit history development. So why does credit limit matters? 75% of college students hold at least one credit card. The credit card has both practical and emotional use. It shapes their satisfaction and spending behavior. Access to credit early affects their long-term outcomes like graduation, earnings, and loan repayments. So what is our question? What do we want to study? We want to know what personal and financial factors influence the credit limits assigned to users and how can understanding these factors help college students improve their creditworthiness and financial stability.
So we gather data from a local bank, and those are the variables we are going to use for future analysis, which are the credit limits on credit card for each users, the age of the users, the card type, their marital status, incomes categories, the total relationship count, which are the number of products held by each customers, the number of months of inactivity in the last 12 months, the number of contacts on the last 12 months, the total revolving balance on the credit card, the open-to-buy credit lines average in the last 12 months, the change in transaction amount from Q4 over Q1, the total transaction amount in the last 12 months, and corresponding transaction count, the change in the transaction count, the average card utilization ratios, the period of relationship with the bank, and the number of dependents a customer has. So with those variables in mind, we are going to examine the factors influencing one's credit limit. And here are the research questions we have. Among education level, income level, total transaction count, total relationship count, and age, do any variables have a significant linear impact on credit limit of the individuals? Does the presence of unknown categories in education levels, income categories, and marital status significantly affect the credit limits? How does the income categories, total transaction amount, and the total transactions count impact the credit limit? Given the number of dependents and the average utilization ratio of customers, what's the linear impact of customer age and the total numbers of transactions on credit limits will be the same. So let's look into the first research questions. So among those variables listed, whether or not any predictor variables have a significantly linear impact on the credit limits of the individuals. We have first checked the assumption of linearity, constant variance, and the normalities as demonstrated below, and we realize there is a huge issues of the raw data. They failed for all of the tests. So we decided to perform a data transformation, which after several attempting, we choose to use the weighted least squares regression, and we also include a remedial procedures, which is robust regressions to take care of the outliers in the original data. So at the end, we get improved models with better linearity and the residuals distributed more normal comparing to the original data. And we also check the multicollinearity between the variables, and they looks pretty well, and we also performed the k-fold validation that is not performed well based on the low R-squared values, but we have seen a slight improvement comparing to the original model with the improved models. And after we have those, we can perform our analysis on the whether among education level, income level, total transaction count, total relationship count, and age, do any predictor variables have a significantly linear impact on the credit limits of the individuals? And with that null hypothesis to be set for all the coefficient to be zero, we perform the linear regression and we get a large F statistics value with a corresponding p-value less than 0.05, which suggests that we will reject the null hypothesis and claim that at least one of the predictor variables above has a significantly impact on credit limit.
For research question 2, I will present the analysis on the impact of unknown values on credit limit. Specifically, we investigate whether missing information in categorical variables, which are education level, income category, and marital status, whether they significantly affect a customer's assigned credit limit. So in this case, we set up null hypothesis that all unknown ingredients have no effect. Let's look onto the model building process. We started with an initial form model including all predictors. As we know that non-linearity and not preferred normality revealed by residual plots and q-plots. To address it, we performed variable transformation. I added a square term for milestone book to capture nonlinear trends and apply log transformations to average open to buy and total trends amount. Although these transformations improve model assumptions somewhat, minor issues remain. To further simplify and strengthen the model, stepwise regression based on AIC and backward selection with k-fold cross-validation are conducted to ensure the model generalizes well to the data. Through this process, we select a final model with 11 predictors, balancing complexity and predictive performance. So final models still have minor deviations from preferred normality. The residual pattern improves significantly compared to the initial model, and the model remains interpretable given the dominance of categorical predictors. Going forward, further improvements will be achieved by exploring flexible modeling methods for categorical predictors. Now, for the hypothesis test. The unknown values in income category has had a highly significant negative impact on credit limit. And in contrast, the unknowns in education level and marital status were not significant. Specifically, customers with missing income information were assigned credit limits roughly $4,000 lower on average.
Okay, moving on to the next research question. We want to know how does the income category, the total transaction amounts, and the total transaction count impacts credit limits. This is more like a spending behavior question. And our hypothesis, null hypothesis will be now then has impacts on the credit limits. And the alternate hypothesis will be at least one of them has impacts whether positively or negatively. So for our model that has linearity, normality, and heteroscedasticity problem. So I implement a transformation on the credit limit, which kind of soft or less make it better for the normality problem. However, the heteroscedasticity problems still exist, so I uses the weighted least square methods as a remedial process. And after implementing the weighted least square methods, so we can interpret our results. So looking at our small p-value can conclude that we can reject the null hypothesis that at least one of the factors has impacts on the credit limits. If we look more specifically, so for the income categories, if we look at the coefficient, we can see that the higher the income level, the higher the credit limits, which is very fair for credit card users. And for total transaction amounts, giving others the same, it has a positive impact on credit limits, which means the more transaction amounts, the more your credit limits goes up. However, for the transaction count, we figure that it has a negative impact on the credit limits, which is given your income and transaction amounts the same. The more transactions you have, the more likely the lower your credit limits will be, which implies that large transactions with small amounts of money might not be a good spending habits for banks.
And for my question, I asked if customer age and total transaction count will have the same linear impact on credit limit given the number of dependents and the average utilization ratio of the customer. So I defined the hypothesis test as the betas for customer age and transaction count being the same. As for the modeling and methods for improvement, the normality assumption and the constant variance assumptions were violated. In order to fix that or to aid with this, I performed a weighted least squares transformation as well as performing robust regression in order to reduce the influential cases. Then I went into the hypothesis testing in the k-folds validation, where in order to perform the hypothesis test, I had to bootstrap the robust regression model, in order to get a distribution between the differences of the two estimate values for the parameters. And then I took the difference between them from across all the samples in order to simulate a normal distribution, which came back then I calculated the confidence interval from there, which included the value 0, indicating that they are in fact we failed to reject the null hypothesis, which means they do have the same linear impact. And as for the k-fold validation, the model doesn't seem to improve too much between having 2 and 4 parameters. So it might have done better, or it might be better for it to have less parameters rather than to have all the model parameters. Now, in conclusion, as we covered in the first question, education level, income level, total transaction count and amount, as well as total relationship count and age are all significant predictors for a credit limit. For our second question, after exploring the impact of unknown information, education levels, and income category marital status, only the unknown category for income significantly reduced credit limit. For our third question, given other factors staying the same, the total transaction amount had a positive impact on credit limit. And for our final question, if the utilization ratio and dependent count are given, age and total transaction count will have the same linear impact on credit limit.
And there are mainly 2 limitations of our models. One is for source of data. The data includes buyers because our data are collected from the customers from one specific bank. And in the original data, there are outliers because the credit limit is set to be 35,000. And there are few people that have low credit limit with high average utilization ratio, generating some serious inferential points. And second is for model that agnostics and improvements. Some predictor variables are hard to fully fulfill all three assumptions checks, even after removal of inferential points. And treating the unknown values in categorical data as an ordinary level assumes that it is comparable to other levels. However, the unknowns may represent very different mechanisms, and that is being able to transfer some of the data in order to preserve the normality of errors assumption is difficult. However, being able to bootstrap samples from the data can help simulate a normal distribution. And we have three potential improvements. The first is improve the dataset by filling in the category on the unknown section of the predictor variables. And second is applying more advanced data transformation and remedial procedures to improve the performance of the model. And third, getting more data from other places. And here is the reference of our presentation. Thank you.